Okay, so what I've done is I have went ahead and did a breakout room. Right now, Abby and Jordan are going through the problems, working them in a breakout room. I'm sorry, I'm videotaping this for the people that aren't here. Okay, so the first thing we're doing is, excuse me, if you check online, you will see you have 10 questions, okay? So what they were doing is they were going through these questions and choosing answers. You notice this first question is something that we did for question of the day. And then you go down to 2, 3, 4, 5, and then 6, of course, we have a figure that we're going to talk about. 7, 8, and then 9, and then 10 is our math problem. And so if you look, whenever I copied it, it didn't really show up really well. So that's m equals 3, and that's the number we're going to be using. And then this is telling us the 35 degrees, okay? So I'm going to get ready to drop them out of their breakout group. We're going to go over the answers together, and then we will see what else, if we have any questions or whatever. So I'm going to close the groups, have them come back in. Hey, Jordan.
Hello.
Did we lose Abby?
I believe she's coming along. There she is.
She just came along. Okay, so what we're going to do is that's 3. So what we're going to do is we're going to kind of go over the answers that we have. We're going to discuss it. I'm going ahead and recording it just in case people that aren't here, like Hayden and them, so they can see it and know what they are. So let's look at the first one. It says in a double slit inference pattern, the path length for one slit on the dark fringe is longer than the path length on the other slit to the fringe by. And what answer did y'all choose?
B.
B, correct. So it's 1/2 of a wavelength. Fantastic. Let's go to number 2 now. Number 2 says in a double slit inference experiment, a wave from one slit arrives at a point of the screen of one wavelength behind the wave from the other slit. What are you observing at this point? What'd y'all decide?
I believe we said B for this one as well.
Yep, and it's a right fringe. Perfect. Okay, so let's look at number 3. It says in a double slit inference experiment, a wave from one slit arrives at a point on a screen 1/2 wavelength behind the wave of the other slit. What is your observation? What do you think it was, sir?
I think this one's B again.
Okay, this one's a dark fringe.
Oh.
Why is it a dark fringe instead of a bright one?
Is it because it's 1/2 and not 1?
Yes, it's because it's 1/2 wavelength behind the wave. And if that is it, then we're going to talk about a dark fringe instead. Are you good? Abby, do you understand?
Yes, ma'am.
Fantastic. Let's go to number 4. Number 4 says, if 2 light bulbs are placed side by side, no inference is observed because, what do you think it is?
This one made me think a lot, but I'm pretty sure it's C.
Yes. Very good. C. Incandescent light is incandescent. Very perfect. Number 5. When we're talking about this is a property by which 2 waves with identical wavelengths maintain a constant. What did you decide on that one?
I said B, frequency.
Okay. So when we're talking about 2 waves, right? Identical wavelengths maintaining a constraint. You think it's frequency, but does frequency consist of two waves?
No, so
Nope, so it can't be frequency. Let's think again. What do you think, Abby? It is C. So when we're talking about two waves, we're talking about a phase relationship. Remember in the reading what they had is they had two waves together, and then what they did is they had, I showed you in the question of the day where you have two red waves, and then you have a blue wave in the middle. That's what they're talking about here. They're talking about that wave relationship. You got it?
yes, ma'am.
Okay. Let's look at the next question. What is that? Do either one of you know?
That's like
This
one of
is-
the experiments we did, right?
Well, it's kind of like the one that we did when we were using the one with the power. I think you were using it, Jordan, on Friday of last week. And remember how you had the little black things that had the slits in it?
Oh, yeah, that's right. The Hudson.
And then you had lights that came out?
Yes, ma'am.
What this is doing, this is showing you that black, except yours maybe had two or three. But this right here is just showing that thing you slid down and showing where the lights are coming out, okay? Or going back in. So it says here, the figure above shows a pattern of a double slit inference experiment. The center of the pattern is located on E. So this is the center. So it says, which fringe represents the second order of minimum? Is it E, which would be the same one? Would it be G? Would it be F? Or would it be H? What do y'all think?
H.
Yes, it is H. Very good. Because if you remember, when we're talking about a dark fringe and a light fringe, right? When we're talking about that, it should be always to the right when we're talking about this type of fringe for second order. If you count over two, guess what? That's your second fringe. So let's look at the next question. Number 7. Acronym for laser stands for light amplification by what emission? This was a term. So which one do you think it is?
Stimulated, D.
Correct, D. And that's just a term. Perfect. And then number 8. A laser can be used to test glaucoma, measure distance, read a barcode, or all the above.
All of the above.
Yes. Now, are they cutting you? No, it's not like Star Wars and it has that, and it cuts you in half. But then the thing that we were using yesterday, okay, and the reason why I wanted you to go online and do the simulation yesterday is it was actually showing you these different ones, wasn't they? So I was hoping maybe that would have helped you because one, it had a woman with her face in a little compartment and the laser shining up, right? Measuring distance, you can actually see that where if you have land surveyors and what they're doing is they are actually shooting the laser across to measure distance. And then barcodes, of course, you're talking about if you go to Walmart or whatever, remember those little cross beams, those red cross beams? What they're doing is those are lasers also that are detecting where that barcode is so we can read it. So yes, it is D. Okay. Let's look at number 9. Which of the following is a process of using light waves to produce more waves, which properly identical to those of the first wave? What do you think it is?
We said A.
Yeah, stimulated emissions. Very good. And then the last one, I'm going to do it for you, and you can just tell me if you got it or not, which I think you're going to. So it's telling you here there's a distance of 2 slits on a double slit experiment that is 0.0025 millimeters, and that it has a third order bright fringe which is M equal to is what it's supposed to say, is measured on the screen by an angle of 35 degrees from the central maximum. What is the wavelength of the light? So, first thing we're going to do is we're looking for the wavelength. If we're looking for the wavelength, that is that, right? Equals D sine over angle over our M. So, first things first, for our D, we're going to have to change that. That has 0.0025 millimeters, and we need to change that to meters. So if we change that to meters, we're going to get 2.5 times 10 to the negative 6 power. Okay? So we have to use that number. I'll mark it down here. To use, because remember, when we're talking about this, it has to be in meters. The next thing that we have is we have an angle, right? So that's our D. So our angle says that it's 35 degrees. And then our M says that we're in phase 3. So what we're going to do is we're going to take our 2.5 times 10 to the negative 6 meters. We're going to do a sine of our angle, which is 35. And we're going to divide that by 3. So let me get my calculator. First thing I need to do is set watt on our calculator.
We made sure it's in degree.
Yeah, so we're going to change our mode, make sure it's in degree. Perfect. So I'm going to do alpha y enter. I'm going to do 2.5 times 10 caret, and I'm going to use the negative number here, 6. And then I'm going to go down 1. I'm going to do sine 35, and then go down, and I get 3. So what answer did y'all get?
I got 4.7 times 10 to the negative 7.
Yep, I got 4.7798036336 E7. So let's ask you a question. If that 7 is where we're going to round to, based on sig fig, because that's 2, why are you keeping that a 7?
Oh, I rounded mine to 4.8.
Oh, okay. I'm sorry. 4.8 times 10 to the 7th power. Was it a positive or a negative?
It was a negative 7.
Perfect. It was a negative. Abby, did you get that?
Yes, ma'am.
Perfect. Well, the only thing I need you to do is, if you would please submit that. So the only thing I need you to do is in your ISM book, just write down the letters that it corresponds with. I think in the instructions, I said if you can paraphrase the question with the answer will be fine with me. Along with number 10, make sure if you do number 10, I want to see all of this, okay? Because I want to see your variables, I want to see your equation, and I want you to see you doing your math. Questions?
All good.
I don't think this was bad today. The only thing I thought, and I know we normally do, we normally do where we do 4 questions, but I thought it would be better today just to make sure I can give you content. But I do want to show you my outfit today. Can you see my pants?
In the Christmas spirit.
They're Christmas trees that match my shirt. So I'm just letting y'all know what y'all missing on Fridays because you're not here. But I'm getting ready to, I'm going to be leaving here and going to Greenville for the weekend, and I'll be back. But I'm in the Christmas spirit already. So listen, I hope y'all have a safe weekend. Love you guys. Submit that for me. If you, I'll put this online so they'll have a video too if they need it, or if somebody reaches out to you and asks you for help for these problems today that wasn't able to come to class today, if you would share that with them, I appreciate it. Monday, we will start remember Monday, you won't have to do anything because Monday is going to be the same question the same reading assignment that I posted this week. So enjoy your Monday off. Do check the question of the day, and I'll have the agenda up for you so you can do the rest. If you want to do Tuesday and get one day ahead, you can. All right, guys?
Alrighty, Miss Long.
All right. Love you guys, and I will see you on Wednesday.
Alrighty.
All right. Bye.